All right, today we're going to do equations and mole calculations, otherwise known as stoichiometry. So stoichiometry is just a comparison of two different amounts of substances involved in a reaction. So that's all we're doing. So we're given the amount of one substance in a chemical reaction, and we're asked to find the amount of a different substance. I know this is not in your notes, but I like to use this to introduce this topic. It's kind of like our example with eggs that we did with conversion factors. So I'm going to start off with a recipe, my recipe for a turkey sandwich. It's pretty simple. You take 2 slices of bread and 3 slices of turkey. You can make one sandwich. So let's say this. Let's say we have, I don't know, let's say 12 slices of bread. If you have 12 slices of bread and lots of turkey, so plenty of turkey, extra turkey, how many sandwiches can you make? Again, just like last time, I'm not looking for a number, not just yet. So let's set it up. We're going to use these ratios here. These coefficients can be used as a ratio. So let's set up our conversion factor. So for every one sandwich, you need 2 slices of bread. So if you have 12 slices of bread, you can make 6 sandwiches. Well, what if you had, I don't know, let's go with 12 slices of turkey. You have 12 slices of turkey and lots of bread, plenty of bread. How many sandwiches can you make? Well, if we have 3 slices of turkey per every 1 sandwich, and if we have 12 slices of turkey, we can make 4 sandwiches. So you're given the amount of one substance, asked to find the amount of a different substance. So in this example, we're looking at, how much reactants you have and how much product you can make from that. It doesn't matter what you're given the amount of and what you're asked to find. It's always the same. Let's take a look at some more examples. Let's say you have 10 slices of bread. How many slices of turkey would you need to make your sandwiches? So this time we're going to compare a ratio of turkey to bread. So again, the unit you want always goes on top, and the units you want to cancel goes on the bottom. So ratio of turkey to bread, 3 slices of turkey for every 2 slices of bread according to our recipe. So if you have 10 slices of bread, you will need 15 slices of turkey. So again, that's a pretty simple example of stoichiometry. You're given the amount of one substance, asked to find the amount of a different substance. Obviously, we're not going to be using bread and turkey and sandwiches, but we're going to be using grams and moles and molecules. So let's see how this works with a chemical equation. So we'll go back to our example of the reaction between hydrogen and oxygen to produce water. Very, very, very important. Before I state what's in the notes, the coefficients in a chemical equation represents the relative number of particles taking place in the reaction. For example, you have 2 molecules of hydrogen that reacts with 1 molecule of oxygen to produce 2 molecules of water. Well, more important than that is knowing this. The coefficients in a chemical equation not only represent the relative number of particles that are involved in the reaction, but also the relative number of moles of those substances involved in the reaction. So coefficients, interpret them as moles. So we have 2 moles of hydrogen that reacts with every 1 mole of oxygen to produce 2 moles of water. Now let's say you had 10 moles of oxygen. And I'm not worried about significant figures here. 10 moles of oxygen. How many moles of hydrogen would you need to react with 10 moles of oxygen? So what we're going to do is we're going to use the coefficients as a ratio, a mole ratio. So anytime we're converting from moles of one substance to moles of a different substance, we'll use the coefficients in our conversion factor as a mole ratio, ratio of moles. So we want moles of oxygen to cancel, so that's going to go on the bottom. The original question was how many moles of hydrogen are needed to react with 10 moles of oxygen. So moles of hydrogen goes on the top. It's more important now than ever to label your conversion factors, number, units, and formula of the substance. So according to our chemical equation, what is the mole ratio of hydrogen to oxygen? Looks like it's 2 moles of hydrogen for every 1 mole of oxygen. So if you have 10 moles of oxygen, you will need 20 moles of hydrogen to react with it. So again, given the amount of one substance, asked to find the amount of a different substance. Let's try this one out. Let's say you had, this time, 8 moles of oxygen. How many grams, this time, grams of hydrogen would we need to react with it? Okay, so it's a little bit different. So this time we're going to, again, start with moles. First, we're going to convert to moles of hydrogen. So let's do that. So 1 mole of oxygen, 2 moles of hydrogen. So at this point in the problem, we have moles of hydrogen. But what did I ask for originally? I said how many grams of hydrogen would be needed to react with 8 moles of oxygen. And so at this point, we know moles of hydrogen. We can convert to grams of hydrogen by using molar mass. Again, I'm not so concerned about the number, more the set. So just know that's the coefficients. They don't give you relative amounts in grams. They don't give you relative amounts in anything else but moles. We will see that they do represent something else later, but for now, just know that they are moles, relative moles. So let's take a look at some more examples. How many grams of carbon dioxide, so very important, that's what we're trying to find, are produced when 15.0 grams of acetylene gas burns? So again, we're given the amount of one substance, acetylene, and we're asked to find the amount of a different substance. All right, so what is our first step? Think about the turkey sandwich example. Think about the example with the reaction between hydrogen and oxygen. Our first step is to write the balance equation for the reaction. So why don't you go ahead and pause the video and write the balance equation for the combustion of acetylene. Pause now, please. So hopefully you got this equation nice and balanced. All right, so let's do this. I like to always label in the equation what we're given the amount of. I call that the given. And I also like to label the unknown, the substance that we're trying to find the amount of. So we are given the amount of acetylene, and we are trying to find the amount of carbon dioxide. So let's start off with the quantity given to us in the problem. We'll start way over here to the left. All right, so we're given grams of one substance, trying to find grams of a different substance. So what do we need to convert to first? Well, given grams of acetylene, first thing we need to find is moles of acetylene. So let's do that. And then we'll plug in the molar mass here at the bottom. Again, very important, cancel as you go. So what do we have at this point? We have moles of acetylene. So if we know moles of one substance, we can use that to find moles of a different substance. And we'll do so by using a mole ratio. So we want moles of acetylene to cancel, so that goes on the bottom. And we're trying to find moles of carbon dioxide. So what is the ratio, mole ratio of carbon dioxide to acetylene? If you want to reduce it, it's fine. I like to use the numbers straight from the balance equation, so there's no doubt about where those numbers came from, especially if it's a 1-to-1 ratio. Is it really a 1-to-1 ratio, or did I just mistakenly put ones there just because I wasn't thinking? So I'm going to use the actual numbers from the equation. Moles of acetylene cancels. Now let's go to the question. Is this what we're trying to find? Moles of carbon dioxide? No, the question asks for grams of carbon dioxide. So given moles of a substance, we can find grams of that substance by using molar mass. All right, there's the setup. Go ahead and calculate this. Pause the video now, please. So you should get 50.8 grams of carbon dioxide. This is how much carbon dioxide should be produced in the reaction of 15 grams of acetylene with lots of oxygen. So we didn't make any mention about the oxygen. So assume that we have lots of oxygen, plenty of oxygen, and that the acetylene is what is determining how much carbon dioxide is produced. In this case, 50.8 grams. All right, so let's take a look at the next one. I'll help you get it set up. What are we looking for this time? So this time we're looking for molecules of oxygen. That is our unknown, oxygen. This time molecules, not grams. How many molecules of oxygen are required to burn 13.5 grams of methane gas? Again, step number 1 is to write the balance equation for this reaction. So let's do that. This is a combustion reaction, just like the last example. And so let's balance this. Let's label in the equation our given and unknown. So we are given the amount of methane. Methane is CH4. And we're trying to find the amount. And notice I just say amounts because amounts could be grams, could be moles, could be molecules. Later on could be liters. So it doesn't matter. So we're given the amount of one substance and asked to find the amount of a different substance. Here the amount we're given is in grams, and the amount that we're trying to find is in molecules. All right, so I'm going to let you set this one up. So go ahead and pause the video and do that now. So here's our setup. We start off with grams of methane converted to moles of methane using the molar mass. Then converted from moles of methane to moles of oxygen using the mole ratio from the balance equation. And then from moles of oxygen to molecules. Sorry, I didn't cancel, but again, cancel as you go. So grams of methane cancels first, and then moles cancels, and then moles of oxygen cancels, and we're left with molecules of oxygen. And we get 1.02 times 10 to the 24th O2 molecules. I'm going to add a word here. That are needed. That's how many molecules of oxygen are needed to react with 13.5 grams of methane. All right, here's another one for you to try. How many grams of copper should be produced from the decomposition of 65.0 grams of copper 1 oxide? All right, so I'm not going to help you with this one at all. Go ahead and write the balance equation, set up your calculation, get your answer. Pause the video now, please. Alrighty, there's the balance equation, there's the setup. If you use 63.6 grams per mole for copper's molar mass, you get a slightly different answer, which is fine. So I use 63.5. So you get 57.7 grams of copper that should be produced. So again, make sure your results make sense. If you have, and make sure you understand what they mean. If you have 65 grams of copper 1 oxide that decomposes, you should produce 57.7 grams of copper metal. All right, let's try another one. This time we have a different type of reaction. Solutions of iron 3 chloride and silver nitrate are mixed. What kind of reaction is this? This is a double replacement reaction. This is a precipitation reaction. So start off with the balance equation for the reaction. Go ahead and pause the video, just do that part. Pause now, please. All right, so this time I included states of matter because if we take a look at letter B, it asks for the grams of precipitate that should form. So we need to know which of our products is the precipitate. So I have two separate calculations for you, B and C. So go ahead and work on those. Pause the video and do those now, please. All right, so here are the results. Follow along with me. So we have our balance equation there, as pointed out before. Let's start off with the 10 grams of iron 3 chloride. If you have 10 grams of iron 3 chloride that reacts, how many grams of precipitate? The precipitate is silver chloride. How many grams of silver chloride should be produced? You get 26.5 grams. By the way, common mistake is using coefficients for molar mass. We don't use the coefficients from the balance equation for molar mass. Remember, the definition of molar mass is the mass in grams of 1 mole of a substance. Remember, we said anytime you have mole in a conversion factor, it will be 1 until next chapter. Well, here we are. And so we may have numbers before moles other than 1 if we're using a mole ratio and the coefficient for that particular substance is not a 1. So don't put a 3 here because it's 3 moles of silver chloride. That's only here for our mole ratio. So this is molar mass. That's always going to be per 1 mole. And then if we look at the silver nitrate, if you start off with 35.5 grams of silver nitrate, you should produce 29.9 grams of silver chloride. Let me give you something to think about. What if you mixed 10 grams of iron 3 chloride with 35.5 grams of silver nitrate? How many grams of precipitate should form? So that's something that we'll talk about in our next topic, something called limiting reactants. But for now, we'll just stick with the stoichiometry. All right, that concludes this lesson. Hope you learned something. Thanks for watching.